Hi, good morning, everyone. Today, we are going to go ahead and talk about ISI. And in ISI, I'm going to go ahead and do the paper 2022 PEA paper. I'm going to go ahead and take the first 8 questions from that PEA paper, right? So let's just write this down. This is ISI PEA 2022 paper. Okay, let us have a look at the first question. This says, consider an economy with two goods X and Y. Let the utility function be given by, so this is a usual Cobb-Douglas utility function, which is given by A root XY, where A is greater than 0, X is greater than equal to 0, and X is the amount of good X and Y is the amount of good Y. And you're also given a budget equation. So budget equation is PX into X plus PY into Y less than or equal to income of the consumer. It says PX and PY are equal to each other. So PX is equal to PY. Tell me something. I'll do it through the long method also, but just tell me something. When we talk about Cobb-Douglas preferences, we have learned something. If my Cobb-Douglas preference is just XY or root XY, whatever, something like that. So or let's take even a general one, X to the power alpha, Y to the power beta. When my utility function is like this, can you tell me what was X star, Y star? X star was alpha upon alpha plus beta M by PX. And Y star was beta upon alpha plus beta M by PY. Right? Now, in this case, if I talk about my utility function, A is just a monotonic transformation. I have just gone ahead and multiplied it with something. That does not change anything, right? A is just a monotonic transformation. My original utility function is just root XY. So if I talk about my original utility function, beta, root XY, then this can simply be written as X to the power half and Y to the power half. So alpha and beta both are half. So if I just take it here, this is going to be half upon half plus half is 1, M by PX. And this will be half upon half plus half is 1, M by PY. So beta, my X star is going to be M by 2PX. And Y star is going to be M by 2PY. And if PX and PY are equal to each other, say let's equal to P, then I will just get my X star as M by 2P and Y star also as M by 2P. So X star and Y star will be equal to each other. They are equal, right? So it will be the case that X star and Y star are in fact equal to each other. That's the first thing. Right? But supposedly it does not hit you like this. ऐसा नहीं समझ में आ रहा through the Cobb-Douglas function. Then also it is simple. Just go ahead and apply the Lagrange. So what will be your Lagrange? I want to go ahead and maximize my utility function. And I want to make it subject to a budget constraint. So my utility function is A root XY, right? And my budget constraint is plus lambda, and this is going to be M minus PX into X minus PY into Y, right? This is what is there, right? So if I just differentiate this with respect to X, I will get A. So basically, you could have done it through third method also, where you would have equated MRS to PX by PY. These are all synonymous. We have done it multiple times in class. They're all equivalent to each other. So root Y into 1 by 2 root X plus lambda into minus PX equal to 0. Similarly, when you will go ahead and differentiate this with respect to Y, you will get a. So root x remains as it is, and differentiation of root y will become 1 by 2 root y plus lambda minus py equal to 0. So when you will divide, just solve these equations, a by 2, y by x under root is equal to lambda px. And then the other equation is a by 2, x by y under root is equal to lambda py. When you will just divide these two equations, you are going to get y by x is equal to px by py. This is your equation that you will get. I am trying to maximize my utility. I have differentiated this with respect to x. I have differentiated this with respect to y. I am trying to maximize my utility. So I just get out of those two conditions that y by x should be equal to px by py. If you remember from our class, actually we concluded from here that we made multiple interpretations out of it. So you have to just remember all those interpretations from our class, okay? But now the question says that px is equal to py. This is what is given to us, that px and py are equal to each other. Does not matter, right, whether both of them actually are equal to 1 or greater than 1. They are equal to each other. So if they're equal to each other, I can just say that px and py can cancel out. So if px is 4, py is also 4, right? So if I just equate the two px and py equal, I will get y star is equal to x star, right? This is what I will get, that I will be consuming x and y in equal quantity. So the answer to this question is, it must always be in this case that x star and y star will be equal to each other. That's the answer. Okay, come to the next question. So it says, consider this is very good question, very, very good. So this says, consider the utility function 3x1 plus 2x2. They have tried to confuse you, okay? This is a substitute good utility function. It's a linear function. And they are asking you to go ahead and maximize it using the method of Lagrange. Let me show you what is the mistake you could have done. If you go ahead and you formulate a Lagrange, if you go ahead and do something like this, 3x1 plus 2x2 plus lambda m minus 2x1 minus 3x2. Suppose I just, this is what is given to me. It is saying the associated Lagrangian function is this, right? It says find x star, y, x2, x1 star, x2 star, and lambda. Suppose I just go using my usual method and I just start with this del L by del x1. It will be 3 plus lambda minus 2 is equal to 0. Then suppose I differentiate this with respect to y, not y, x2. I will get 2 plus lambda minus 3 equal to 0. So this will give me 3 is equal to 2 lambda. So lambda will be 3 by 2. This will give me 2 is equal to 3 lambda. So lambda will be 2 by 3. This is not possible. Lambda, if you remember, is the marginal utility of income. And I cannot have two values of lambda. I can only have one value of lambda. So if I start, because this is a linear function, if I start following this, I will never ever be able to solve this Lagrange. Never. So how do I go about it? I will go about it in the usual method that we have been following. So I'm given a substitute good utility function. So u of x1 comma x2, this is given to me as 3x1 plus 2x2. So if I were to go ahead and find MRS of this utility function, it will be mu1 by mu2. So if I differentiate the utility function with respect to x1, I will get 3. If I differentiate the utility function with respect to x2, I will get 2, which means that if I were to find my MRS, it will be 1.5. Now let's find the ratio of Px by Py. So it is given to me that my budget line is 2x1 plus 3x2 less than equal to income of the consumer. This is what it says. 2x1 plus 3x2 less than equal to income of the consumer. So Px1 will be 2. Px2 will be 3. So Px1 by Px2 will be 2 by 3. 0.67. Right? So now let's compare. We know that MRS is greater than P1 by P2. This implies whenever this condition occurs in substitute goods, MRS is greater than P1 by P2, you consume only good 1. So only good X1 is what I will be consuming. Now, if I will be only consuming good X1, put it back in the budget line. My budget line is 2x1 plus 3x2 is equal to M. 2x1 plus 3 into 0 is equal to M. I am not consuming x2. So 2x1 is M. So x1 is M by. So I have got that I will be consuming x1 equal to M by 2. Just for our sake. Just for our sake. If I were to draw the budget line has a slope of 0.67. So the budget line is going to turn out to be flatter. And the ICs will be steeper. So my ICs will be like this. Like this. And my aim is to reach the highest IC possible. So I will be reaching this point. This will be my equilibrium point. And here I will be consuming only good X1. So this is good X1 and this is good X2. Right? Now, I know that X2 is 0. So I am going to go ahead back to my Lagrange. I am going to resolve this Lagrange putting X2 as 0. So let's just take this Lagrange again. And I'm going to just put X2 as 0. So let's put X2 as 0. And my Lagrange will be 3x1 plus lambda m minus 2x1 minus 3 into 0. So this is going to be 3x1 plus lambda m minus 2x1. This is what my Lagrange will be. Again, I will differentiate. I will try to maximize the amount of x1 that I consume. So differentiate it with respect to x1. So 3 plus lambda into m. Sorry, 3 minus 2 lambda will be 0. So this means that 3 will be equal to 2 lambda and lambda will be 3 by 2. This is how you can go ahead and solve this question. So the aim here is to understand that you cannot differentiate Lagrange directly. It will give you a wrong answer. You have to use the concept of the usual substitute goods and then solve for the value of lambda at the end after putting x2 as 0. Okay, come to the third question. It says consider a two-good economy where the two goods are X and Y. Okay. And consider consumer A and B. Okay. In a month where the price of good X was 2. So it says price of good X is 2. And it says that the price of good Y is 3. Okay. So my price bundle is 2, 3. Consumer A consumes 3 units of X and 8 units of Y. Okay. And B consumes 6 units of both the goods. All right. In the next month, when price of good X is 3 and price of good Y is 2. Okay. So price of good X is 3 and price of good Y is 2. So my bundle becomes 3, 2. All right. A consumes 8 units of good X and 3 units of good Y. And B consumes 4 of X and 9 of Y. We have to talk about warp and not only warp. Okay. So here is the thing. First of all, I need to go ahead and I need to make a matrix for individual A. So let's make the matrix for individual A. I'm going to take prices here and I'm going to take my bundle here, right? So the prices that I'm given, the two kind of prices I am given are 2, 3 and 3, 2. So let's write them down. The prices are 2, 3 and the prices are 3, 2. And the bundles that I'm just doing it for A. So the bundles that A is going to consume can be 3, 8 or 8, 3. So I'm going to just write them down, 3, 8 or 8. These are my bundles that I will have. Right? Now, see, I need to find the expenditure that I am going to incur on each bundle. So when my bundle is 3, 8 and my price is 2, 3, what is my expenditure, beta? It is going to be 2 into 3 plus 3 into 8. So this is going to be 6 plus 24, which is 30, right? Then what will be my expenditure if the price is 2, 3, but the bundle is 8, 3? So 2 into 8, that is going to be 16 plus 3 into 3, that's going to be 9. So it's going to be 25, right? Now, when my price is 3, 2 and bundle is 3, 8, it's going to be 3 into 3, 9 plus 16, which is 25. And when my price is 3, 2 and bundle is 8, 3, it is going to be 24 plus 6, which is going to be 30. This is what is the expenditure. Now it tells me that individual A, he is consuming, so what does it say? He is consuming bundle 3, 8 at price 2, 3. So he is consuming this bundle at price 2, 3. So let's write this down. So A consumes 3, 8 at price 2, 3. When he consumes 3, 8 at this price, is the other bundle affordable? It is. The other bundle just costs him 25. So at this price, 8, 3 is affordable. He could have bought 8, 3, but he preferred buying 3, 8. So when one was purchased, second was affordable, which means he showed his preference towards the first bundle. So if I name this bundle as X and this bundle as Y, we can say that he purchased this bundle when the other was affordable. So he showed his preference that he prefers X over Y. Now let's flip this. Let's change it. So let's say that now when the prices are 3, 2, what is happening? So at 3, 2, which is the bundle he's buying? At 3, 2, he's buying 8, 3. So he purchases 8, 3 bundle. But is the other bundle affordable? It is, right? When he can spend 30 rupees, 25 is affordable. So when he purchases this bundle 8, 3 at this price, the bundle 3, 8 is affordable. So he shows that he prefers Y over X. This is problematic. Once he is preferring X over Y, once he is preferring Y over X, that means that he is not satisfying war, right? He is not satisfying war. So we can say that, therefore, consumer A is violating war. Please write down this statement that consider two bundles, A and B. If A is purchased when B is affordable, then it should not be the case that B is purchased when A is affordable. Otherwise, it would violate what? So if A is revealed preferred to B, B should not be preferred over A. Then violating what happens? And this is what happens in the first case. Let's quickly do it for person B. Person 2, I will make the same matrix beta. So the matrix is going to consist of prices and bundles. So my price that I have is 2, 3 and 3, 2, 2, 3 and 3, 2. And the bundles of B at 2, 3, he was preferring 6, 6 and then 4, 9. So 6, 6 and 4, 9. So what will we have? Find out the expenditure quickly. So 6 into 2, 12 plus 18, which is 30. 8 plus 27. Achha, so one more thing. This is going to be 35. In variant, it proves it by checking whether you have stars or not. It's the same method. You can use that also. Here it will be 6, 12, 18 plus 12, which is 30. And 4 into 3, 12 plus 18, which is 30. He is preferring this bundle at this price and this bundle at this price. This is my bundle, this is my price. So again, I will name this as X and Y. When X is preferred at this price now. So he's spending 30 rupees. He cannot afford 35. So Y is not affordable. And when Y is preferred, then X is affordable. This is fine. I preferred Y when X was affordable, but I preferred X because Y was not affordable to me. So Y was not there in the picture itself, right? So this satisfies what? So the answer to this question should be B satisfies war, but A does not. Okay, come to the next question. It says, let the production function be min, where L and K are the amounts of labor and capital respectively. Consider the cost function WL plus RK, where W is greater than 0. Suppose L star K star is the combination of labor and capital, such that you have to produce a minimum level of output, of course. Then, very simple. This is a very simple question, not at the level of ISI. So you just have to use this function. This is a min function. At min function, whatever comes inside the min function must be equated. And it must also be equated to Y. I need to produce a minimum of Y bar. So I will equate it to Y bar. So I will get L star is equal to Y bar by 2. And K star will be equal to Y bar. Simple. So my answer to this question will be C. So we will produce along the line of king. And at that king, when I have labor here and capital here, this equation will be satisfied that 2L will be equal to K. So if K will be 1, L will be 2, and this will be my line of king. These will be my ISO quants. Then this will be my ISO cost line, and this will be my equilibrium. And at equilibrium, this will be labor and this will be capital, right? Okay, come to the next question. This is easy. This is saying, consider the production function min of, consider the, suppose that there are two firms, 1 and 2, that produces the same good. Let the inverted demand function be this. Firm 1 produces Q1 greater than equal to 0 and firm 2 produces Q2 greater than equal to 0. Same. And then you're given the cost as Ki, Qi, and there is no fixed cost, then find the Coulomb equilibrium. By now, actually, it should be on your tips that when the costs are not equal, when the costs are not equal, when you have different marginal cost, what is the output of the firm? What is the profit of the firm? Yes, sir, you should remember this by now, right? But still, I will go ahead and do a complete thorough proof of this. So let's say that the price is given to us as 1 minus Q1 minus Q2, right? The cost function is given as Ki, Qi. So it will be K1, Q1 and K2, Q2. Now this says find out the profit. So profit of firm 1. This will be revenue minus cost. So revenue will be price into quantity of firm 1 minus cost of firm 1, right? So price is 1 minus Q1 minus Q2 into Q1 minus K1 Q1. So I need to find out how the profit changes as Q1 changes. I have to differentiate this with respect to Q1. I will write down one more step in between for ease. So you could have written this as Q1 minus Q1 square minus Q2 Q1 minus K1 Q1. So if I differentiate it, I will get 1 minus 2 Q1 minus Q2 minus K1 equal to 0. So I will get Q1 is equal to 1 minus Q2 minus K1 by 2. We know this is the reaction curve of firm 1 as a function of Q2. Now these profit functions are symmetric in nature. They are symmetric. So if I were to find the profit maximizing quantity of firm 2, I don't have to start solving this again. I can just say that, okay, Q2 will be 1 minus Q1 minus K2 by 2. They are symmetric in nature, so we don't have to go ahead and solve them literally, right? Now, what you can go ahead and do is just solve these two reaction functions simultaneously. So let's just go ahead and do that. So what will I get? So from here, this Q2 can be replaced with this thing. So I will get Q1 is equal to 1 minus Q1 minus K2 by 2 minus K1 by 2. So I will get 2Q1 is equal to 2 minus 1 plus Q1 plus K2 minus 2K1 by 2. So 4Q1 is equal to 1 plus Q1 plus K2 minus 2K1. So 3Q1 is equal to 1 plus K2 minus 2K1. So Q1 will be, Q1 star kar do, 1 plus K2 minus 2K1 by 3. This is what your Q1 star is going to be. You can also find Q2 star. I told you they are going to be symmetric. So Q2 star will be 1 plus K1 minus 2K2 by 3. What will be your price? Price will be 1 minus Q1 star minus Q2 star. So 1 minus 1 plus K1 minus 2 K2 by 3 minus 1 plus K2 minus 2 K1 by 3. So if I were to solve the price, this will come down to what? 3 minus 1 minus K1 plus 2 K2 minus 1 plus K2, not plus K2, minus K2 plus 2K1 by 3, right? This is what the price is going to be. So it is going to be 1 plus K1 plus K2 by 3. This is your price. Now it is asking you to find the profit of firm 2. Just do that. So profit of firm 2 will be price minus its marginal cost into its quantity. Right? So price I found out as 1 plus K1 plus K2 by 3 minus K2. And the quantity that I found out was this 1 plus K1 minus 2K2. So 1 plus K1 minus 2K2 by 3. So if you solve this, actually, it will be 1 plus K1 minus 2K2 whole square by 9. This will be your answer. This is very similar to the Kuno models we have done. In the past, I have done when C1 and C2 are two separate marginal cost. What is going to happen? So it's just that. So the answer would be 1 minus 2K2 plus K1 whole square by 9. Okay, come to the next question. Which of the following statements is correct in a two-world economy? This talks about diminishing marginal utility and the connection of that with diminishing marginal rate of substitution. So it talks about marginal utility versus marginal rate of substitution. Now just think about this. For a well-defined preference, my IC looks like this, right? This is O, X, Y. This is my utility function. And for this utility function, if I were to find MRS, MRS will be MUX by MUY, right? We know that as consumption of X increases, the utility I get from X, the marginal utility of X decreases, it diminishes. So we know that this decreases. And we know that as Y increases, right, then marginal utility of Y also decreases. So when I go from point A to point B, X is increasing, so its marginal utility decreases. Y is decreasing, so its marginal utility increases. So when I find this ratio decreases. So we know that this decreases. We know that this decreases. So we are going ahead and we are talking about diminishing marginal utility for both the goods. When I assumed that we have diminishing marginal utility for both the goods, then I think we are coming to some conclusion. We are going towards MRS being diminishing. But there is another thing I need to check, right? If I want to have a diminishing MRS, I need to go ahead and I need to ensure that when I differentiate my MRS with respect to X, this should be negative. As X should increase, my MRS, my slope should diminish. I should be going from steeper to flatter. This is what I should be doing. So this condition should be satisfied, right? In order to show that this is diminishing. Now what I can go ahead and do? I can go ahead and I can maybe use the formula that MRS is MU1 by MUX by MUY. And let's try to take log on both sides. So ln MRS will be ln MUX minus ln MUY. And I need to differentiate this with respect to X because I need to find this condition. So what will I do? 1 by MRS into del MRS by del X is equal to 1 by MUX into del MUX by del X minus 1 by MUY into del MUY by del X will be this is my equation. I want this to be negative. Achha, one more thing. Some students tend to put this as 0. That's incorrect. Just think about this. If your utility function, let's say, is x square y square, if I differentiate my utility function with respect to y, I will get x square 2y. This will be marginal utility of y. At any point, can't I just differentiate marginal utility of y with respect to x? I will get 2x into 2y. I will get 4xy. That's not 0. Marginal utility of y can be a function of x and y both, right? So that's not incorrect. So I can differentiate it with respect to x. Okay, so coming back here then. So what is there now is that my del MRS with respect to x will be MRS by MUX into del MUX by del x minus MRS into MU upon MUY del MUY by del x. And I want this to be negative. So if I want this to be negative, what is the condition I will have? I will have MRS by MUX del MUX by del x less than MRS by MUY del MUY by del x. So even if I cancel this out, this is the condition that I will have, right? This is my condition, right? So now if I just compare it back, so if I say that, marginal utility is diminishing means I understand that MUX by del MUX by del x, this is negative. I understand that this is negative. But just it being negative does not resolve this problem, right? It does not go ahead and resolve this problem. So therefore, just saying that, this is negative, it does not tell anything about this condition being satisfied. So therefore, we cannot say that just because my marginal utility is diminishing, of one good, I've just taken it up for one good, right? For this good, it does not mean that it is going to go ahead and make sure that's neither necessary nor sufficient for my MRS to be diminishing, right? So we are going to go ahead with option D because I need more information on that. I need what is going to be this sign, right? So I cannot comment on diminishing MRS just based on this being negative. This can also very well be negative and it can be -4 when this is just -3, right? So we cannot comment on this further unless we know the next sign of this thing. So it is neither necessary nor sufficient for diminishing MRS. Okay, come to the next question. This says, a non-transitive preference relation can be represented by a utility function. Now, we know that there are two things that I possibly need for the representation of a utility function. So utility function possibly needs these two conditions among many, right? For a well-defined, we have done what all we need, right? But I at least need completeness and transitivity. If transitivity is violated, I can not represent it by a utility function anymore, right? I need to go ahead and define a utility function only if it is transitive, only when I think more would be preferred. So non-transitive preference relation can be represented by a utility function? Never. It cannot be represented by a utility function. So now let's go to the next question, question number 8. This is the last question I'm going to go ahead and take. So Rahul consumes two goods X and Y in amounts X and Y respectively. Rahul's utility function is given by min of XY. Rahul makes rupees 200. The price of X and price of Y both are 2. Okay. Rahul's boss is thinking of sending him to another town where price of X is 2 and price of Y is 3. He offers no raise in pay. Okay. Rahul, who understands compensating and equivalent variations perfectly, complains bitterly. He says that although he doesn't mind moving for its own sake and town is pleasant, having to move is as bad as cut in pay of rupees A. As bad as a cut in pay of rupees A. So we have to find out how much is a cut in pay for him, right? In his current location. So let's just think about this. His utility function is given by min of xy. We know that when it talks about a min function, I need to equate x to y. This is my equilibrium condition. Right? Now, if I talk about my budget line, and I need to talk about my budget line in the new city, then what is my budget line? The prices are given to me 2 and 3. So Px is given to me as 2 and Py is given to me as 3. So my budget line, it is going to be 2 into x plus 3 into y is equal to income of the consumer. His income is unchanged. He is still getting rupees 200. So his income is still 200. So I will have 2 into x. 2x and y are equal, plus 3 into x is equal to 200. So which means 5x will be 200. So x will be 40 and y will also be 40. So if he moves to the new city, please write down the statement that if he moves to new city, he can only consume 40, he can only afford 40 units of each good. Let's think about this. If he were to consume this 40, in his current city, so in his current city, this 40, if he were to consume that, the price of good X is given to me as 2 and price of good Y is also given to me as 2. So Px is 2 and Py is also 2. So his Px into X plus Py into Y, this will be 2 into 40 plus 2 into 40. This is equivalent to 160. So if he just has 160 rupees, then he can go ahead and he can consume the same bundle that he is consuming in the new city using 200 rupees. So he would need 40 rupees less in this city, right? He would have to need 40 rupees less in his current city and he can still consume the new bundle. Alternatively, we are saying that he is losing he is not able to consume more. He's only able to consume 160 rupees worth of goods when his income is 200. So it is, so now just come to the question. So it says, having to move is as bad as cut in pay in his current location. So in his current location, it is equivalent to just having 160 rupees. Then also he can consume the same bundle that he consumes in the new city. So therefore, it is equivalent to a cut of rupees 40 since he can consume 40, with income of 160. He does not need 200. He can consume that with income of 160. Come to the second part now. The second part says, he also says that he would not mind moving there. When he moved, he got the raise of B. So now let's look at the second part. So in his current city, the prices are 2, 2, right? His budget line is Px into X plus Py into Y is equal to M. Px is 2 into X plus Py is 2 into Y. Income is 200. X and Y are equal. So 2X plus 2X is 200. So 4X is 200. So X will be 50. So what is he consuming in his current city? He is consuming his consumption bundle. That is 50, 50. Now he wants to be the same. He wants to remain intact. So which means he wants that his consumption bundle, even in the new city, should be 50, 50. So in the new city, the price ratio, the prices are 2, 3. So 2 into X plus 3 into Y, that should be equal to his income. He wants to consume the same bundle that he was consuming earlier. He does not want to stop that. So 2 into 50 plus 3 into 50 is equal to M. So M is equal to 100 plus 150, which will be 250. So if he gets 250, he will be able to afford his original bundle. So how much more does he need? He needs 250. He's already getting 200. So he needs a raise of 50. So let's go back now. So he needs a raise of 50. Alternatively, currently he's facing a cut of 40. So answer is A 40 and B 50. B is the right answer. I hope this is making sense. It's very simple. You just have to think that what money do I need so that I can afford the same bundle at new prices, right? And the other thing that we are asking is that if I have to afford the bundle that I'm affording at higher prices now, then how much less money do I require, right? So this is what this question was about. It's a good question that helps you understand both the compensating and equivalent variations in the same part. Okay, so we'll stop here for today.